Next, we're going to talk about graphs of functions. The process is the same as you graph a function in one variable. You plug in values for your x, you evaluate the function, you have a bunch of points in xy plane, connect them together, and have the graph of function in one variable. Now that you have a function in two variables, you plug in different values for your x and y, evaluate the function for z, and then you have a bunch of points in xyz plane, connect them together, and have a three-dimensional object. Sometimes you project the function, the graph of the function, in xy plane or on xz plane or on yz plane to analyze the function itself. One method is using level curves. So when you have a function in two independent variables like x and y, it's easier to visualize the function, the graph of the function in xy plane. What are we going to do? We're going to take the function and we set it equals to a constant like k, and we call it level curves of the function. Especially in differential equations, ordinary differential equations, finding level curves is very helpful. This is an example using level curves in understanding the family of solutions of this differential equation. Dy over dx equals to xy squared divided by 2 minus x squared. Okay, let us get back to calculus. Here you have a three-dimensional object and you slice the graph of the function horizontally, and the projection are just some circles in xy plane. So suppose you slice the function horizontally here. This slice, the intersection with this horizontal plane and the graph of the function is going to be just some circles. The projection on xy plane gives you some circles. And let us take a look at one example to feel more comfortable about this concept. Here you have a function in two independent variables, x and y, 6 minus 3x minus 2y, and your goal is to find level curves of the function for given values of k. Please pause the video, think about this question, then we solve the question together. Very well, to find the level curves of the function, we set the function equals to a constant like k. In this question, k values are given. So one by one, you plug them in and solve for these values and graph the function. When k is equal to -6, you have 6 minus 3x minus 2y equals to -6. So you can write them in nicer form. The equation of the line is 3x plus 2y minus 12 equal to 0. Very well. You know how to graph this line. This is a decreasing line in xy plane. When k is equal to 0, you get second equation, 3x plus 2y minus 6 equal to 0. The graph of the function is here. These two lines are parallel to each other. When k is equal to 6, here you have 3x plus 2y equal to 0. Very well, another parallel line. And finally, when k is equal to 12, here you have equation 3x plus 2y plus 6 equal to 0. And finally, you have the last line. I encourage you to plug in other values for k and actually graph the rest of the lines to have more level curves for this function. Next example. Here you have a function, g of x and y equals to square root of 9 minus x squared minus y squared. The function is just a square root function, and the question says, find level curves for given k values. Please pause the video, solve this example, then we go over the solution together. Very well, we take the function and we set it equals to k to find level curves of the function. So first of all, we can write this in nicer format because we have x squared and y squared inside the radical. We can raise both sides to 2 we get 9 minus x squared minus y squared equals to k squared. And eventually, x squared plus y squared is 9 minus k squared. If you remember equation of a circle, x minus h squared plus y minus k squared equals to r squared is equation of a circle with center at h and k and radius r. So if you compare these two equations, you see this guy is equation of a circle centered at the origin and radius is square root of 9 minus k squared. Okay, here we have different values for our k. K can be 0, k can be 1, k can be 2, k can be 3, and k cannot be 4, for example, k cannot be 5, for example, because it's out of the domain of the square root. Now let us graph the level curves for this function. When k is equal to 0, you have x squared plus y squared equals to 9 minus 0, which is this larger circle. When k is equal to 1, you have x squared plus y squared equals to 8, which is this inner circle. When k is 2, you get x squared plus y squared equals to 9 minus 4 equals to 5, a smaller circle here. And finally, when you plug in 3 for your k, you get x squared plus y squared equal to 0. The only solution for x squared plus y squared equal to 0 is the origin. So these are level curves of this function. Another example, sketch some level curves of the function for x squared plus y squared plus 1. Note that k is not given here, so you need to come up with some k values and graph these level curves. Please pause the video, solve the question, then we go over the solution together. Very well. To find level curves of the function, we set the function equals to k. Then we try to write the function in the format that we saw it before. In this case, first you have plus 1, which is a constant. Let's subtract 1 from both sides. You get 4x squared plus y squared equals to k minus 1. Very well. If you remember conic sections, it's very similar to an ellipse. So let us divide both sides by k minus 1. Then you have x squared divided by a fourth, k minus 1 plus y squared divided by k minus 1 equals to 1. Very well. First of all, k cannot be 1 because it's on the denominator. Then, if you remember, three-dimensional objects, you don't remember those, here's a classification and list of them for you. Here you have an ellipsoid, then you have hyperbolic paraboloid, elliptic paraboloid, and a hyperboloid of 1 sheet, 2 sheets, and a cone. By using a graphing calculator or using a graphing software, there are some online graphing softwares available for you. You can graph the function. This is just an elliptic paraboloid. And level curves are just ellipses in XY plane. As I mentioned, there are different websites, there are different softwares that you can use for 3D surface plotting. If you go to the website academo.org, you can click on 3D surface plotter and you can give the website different functions. Here you can just write down x squared. Let us write plus y squared and then graph the function. Very well. You can just change these variables, the exponents, and you can visualize the graph of the function. Finally, we can add more independent variables like time to the function, and we define a function dependent on time. For example, take a look at this function, f of x, y, z equals to 1 divided by square root of x squared plus y squared plus z squared minus 1. First of all, you can evaluate the function, then you can find the domain and range of the function. Please pause the video, solve this question. Very well. To evaluate the function, you just plug in 1 for x, 3 for y, negative 4 for z. You get 1 divided by square root of 25, which is 1 over 5. The domain of the function, first of all, note that here you have square root function, so the quantity inside the function cannot be negative. X squared plus y squared plus z squared must be greater than or equal to 1, but we have to exclude 1 since this quantity is on the denominator. So that's the domain of the function. By looking at the domain of the function, you can easily find the range of the function, which is 0 to positive infinity. As I mentioned before, if you have a function in 2 independent variables, you use terminology level curves. But when it comes to functions with 3 independent variables, you have to use the word and terminology level surfaces. For example, take a look at this function. F of x, y, and z is equal to x squared plus y squared plus z squared. In this case, you have 3 independent variables. To graph level surfaces, you can plug in different values for your k. K is equal to x squared plus y squared plus z squared. K can be 1, k can be 2, 3, 4, 5, any number that you like. Note that k cannot be negative because you have x squared plus y squared plus z squared equals to a number. And if you graph those, you have some spheres with the exact same center. These are level surfaces of this function. This function, if you want to graph it, it's going to be very hard because it's a 4-dimensional object.